A model that is intended as a means is just as legitimate as another when achieving the same ends, whether it is based on hypothesis or speculation. Some things are simply not testable, yet our intuition leads us eventually to the means of their discovery. We as humans cannot be all-seeing, but can have a glimpse of what we believe is a truth. The paradigms we forge generally lead us to the ends we seek. If to consider our world as a derivative of many phenomenal things, may I request your interest in learning about the theory of relative gravity, aka an object-oriented design for unification theory. Relative gravity describes in its own way the mechanics of the universe. We're not challenging accepted theory, but it is unconventional in view.
Imagine, if you will, a universe not as a vast expanse of empty space punctuated by stars, planets, and galaxies, but as a complex, ever-changing plasma of alternating currents. What if gravity, the force that binds all matter together, is not a standalone phenomenon, but an integral part of a larger, more intricate system? Welcome to the world of Orion Daley's theory of relative gravity. The theory of relative gravity is a novel, object-oriented approach to understanding the universe. It presents the cosmos as an interconnected system, much like a complex piece of software. This theory operates under the assumption that symmetry is conserved through the polymorphism of inherent properties. In simpler terms, it suggests that the universe maintains balance by allowing properties to take on multiple forms. The waves of time are long and deep, and within them there is room for randomness. Yet, even in this randomness, a certain symmetry persists. The four known forces in the universe, the Electro Strong and Weak, Electromagnetism and Gravity, may seem distinct, but according to the theory of relative gravity, they share a symmetry, differentiated only by their context. Consider for a moment the enigmatic relationship between dark and light matter. The theory of relative gravity views this relationship as one of impedance, with particles, galaxies, and all bodies in between perceived as manifolds possessing common and inherent properties. This theory suggests that particles can have opposite charges and exhibit harmonics of vectors for strings with wavelengths that can be distorted. Output: bodies within the universe are not static. They are dynamic, subject to change and distortion. They are skew-able and cumulative, affected by other bodies within their context. In this grand cosmic ballet, gravity is the fundamental relationship, the unseen thread that weaves through all. It is not a standalone force, but a result of superposition, the overlapping and adding up of different forces and effects. In summary, the theory of relative gravity offers a revolutionary perspective on the universe. It views the cosmos as a system of interconnected parts, conserving symmetry through polymorphism. It sees the four known forces in the universe as sharing a symmetry, differentiated only by context. It presents a new understanding of the relationship between dark and light matter, viewing it as one of impedance. It perceives bodies in the universe as skew-able and cumulative, their properties and behaviors shaped by their context. And at the heart of it all, it posits gravity as a result of superposition, the fundamental relationship that binds everything together. This theory, as complex as it may seem, is a testament to the intricate beauty of the universe. It is a reminder that there is still so much to discover, so many questions to answer, and endless possibilities to explore. And gravity, the force that keeps us grounded, is at the very center of it.
Days, I've been captivated by the underlying symmetries that seem to pervade seemingly disparate aspects of existence. Whether observing natural phenomena or the principles governing them, I've consistently noticed a harmonious order at play. This inclination towards symmetry extends not only to the observed world but also to the observer, emphasizing the interconnectedness of all things. In the realm of physics, this quest for symmetry finds expression in what's known as unification theory, famously associated with luminaries like Albert Einstein. This theoretical framework endeavors to reconcile the four fundamental forces of nature within the context of the Big Bang theory, striving to elucidate the underlying unity amidst apparent diversity. However, while unification theory represents a commendable effort, it still lacks the requisite coherence. To address this gap, A synthesis incorporating quantum mechanics, relativity, string theory, and classical mechanics becomes imperative, each contributing a facet to the overarching narrative of cosmic mechanics. In my attempt to conceptualize the mechanics of the universe, I've adopted an object-oriented approach to unification theory. By treating abstract properties such as force as concrete entities with discernible attributes, this paradigm allows for a more tangible understanding of the underlying symmetries. Central to this conceptual framework is the notion of relative gravity, a theory that endeavors to harmonize the four forces through the lens of inheritance and polymorphism. By acknowledging the shared properties underlying diverse manifestations of force, relative gravity provides a coherent framework for understanding the dynamics of the cosmos. In this paradigm, the evolutionary trajectory of the universe assumes an object-oriented perspective, wherein polymorphism ensures the perpetual creation and conservation of physical properties. This conceptualization not only accommodates the abstract principles governing the cosmos, but also their concrete manifestations, from the Big Bang to the present. Moreover, relative gravity offers a novel perspective on the enigmatic nature of time, reconciling apparent paradoxes between quantum mechanics and general relativity. By contextualizing time as a relative concept, this theory transcends conventional limitations, offering insights into the fundamental nature of reality. Fundamentally, relative gravity sees the universe as a dynamic interplay of alternating currents, akin to an infinite alternator generating cosmic energy. In this paradigm, the singularity of the Big Bang emerges as a derivative of this primordial current, with alternating currents serving as the fundamental metric for measuring cosmic phenomena. Ultimately, relative gravity provides a holistic model for understanding the universe, wherein symmetry and harmony pervade all levels of existence. By embracing an object-oriented perspective, this theory offers a unified framework for interpreting the cosmos, from subatomic particles to celestial bodies. Object-Oriented Design for Unification Theory, aka Essay on Relative Gravity by Orion Daley. Theory is theory by design. Object-oriented design allows theory to be extendable. Object-oriented design provides the framework for such evolution. Orion Daley's groundbreaking work on relative gravity presents a paradigm shift in understanding the universe through an object-oriented lens. In this framework, the universe is likened to a dynamic plasma of alternating currents, where symmetry is maintained through polymorphism of inherent properties. At its core, Daley's theory posits that the universe operates on the principles of symmetry and randomness, coexisting within the framework of four fundamental forces: the Electro Strong and Weak, Electromagnetism, and Gravity. These forces, while distinct in context, share underlying symmetrical properties. The interplay between dark and light matter is conceptualized as impedance, where particles, galaxies, and other celestial bodies are viewed as manifolds with shared properties. Gravity emerges as the fundamental force governing their relationships through superposition. To illustrate this concept, consider the Big Bang as a manifestation of vector ZR intersecting with instances of itself, akin to AC current in phase. This intersection gives rise to a manifold of dimensions XYZ, evolving over relative time. The concept of a uniform relative force, URF, further elucidates this relationship, where force diminishes with distance according to the inverse square law. This principle underscores the malleability of spacetime, subject to skewing and distortion. Central to Daley's theory is the notion of relative representation, where fundamental particles exhibit polymorphic properties conserved across interactions. Their relationships are defined by levels of superposition, balancing forces to achieve equilibrium. Spacetime, depicted as a sinusoidal waveform, encompasses infinite possibilities, from expansion to contraction, echoing the cyclical nature of the universe. Each phase of alternating current constitutes a distinct reference frame, influencing the perception of time and dimension. The concept of a dark fabric emerges from this framework, where black holes serve as alternating currents woven together by relative spacetime. Stephen Hawking's conjecture of 100 million black holes per cubic light-year finds resonance within this model, illustrating the intricate interplay of probability and reality. In conclusion, Daley's object-oriented design approach to unification theory offers a novel perspective on the dynamics of the universe, bridging the gap between theory and observation through the lens of symmetry, polymorphism, and relative gravity. On the nature of the universe. To view the universe in the form of alternating currents, as an alternator, all properties can be considered conserved in expression. For an object-oriented paradigm to suit polymorphism, conservation of properties is required to be inherent. Using this approach, the mechanics of relative gravity address the dynamics of what is referred to as a relative force for the universe. Considered common between the four known forces, the mechanics describe relative force as the common property or combination of shared properties which are observed in conservation. At the most fundamental or basic level of measure, these properties consist of energy that exists in some realm of context of time and dimension. Things are considered related by the sharing of properties that are seen as fundamental between them. As a basis for symmetry, a relationship can be seen established with respect to disposition. Newton and Kepler are understood to view a solid object's disposition, like matter, to express force as a fundamental in a relationship between entities when one is acted upon by another. But like solid objects or even for light, the exchange of dispositions between even an anode and cathode are considered to share similar fundamental properties. Solid objects like matter are further affected by or effect a discharge of electrical energy. Here, they are considered to share the same fundamental properties consisting basically of some measure of energy, the speed of light and an aspect of dimension. Addressing this, relative gravity's abstract definition is, a. the potential energy of bodies purported as amplitude in kinetic energy, and expressed as some spatial time in the form of a resonant frequency potential that is shared between them. B. the resonant frequency is considered a shared fundamental that is measured through their body's level of superposition. C. the kinetic expression is subject to the disposition of the body's potential uniquely. Modeled as an object-oriented paradigm, relative gravity is to demonstrate properties of symmetry for the four known forces. It is intended to be analogous to an Occam razor. This is where, although separate and distinguishable, contrary to popular thinking, here all forces are seen as part of the same thing. Like in the case of light, properties are considered polymorphic in an object-oriented hierarchical way. As theory, this is specifically in the nature of how, like a water droplet demonstrates its body in the vacuum of space, black holes, galaxies, matter and particles are held together in a manifold of what is referred to as a uniform relative force, or earth. Earth model is considered a basis for unification theory for the four forces in relative gravity. Relative force is seen as what is common between them when given their context in space and time. As a paradigm, relative gravity, RG, includes the proposal of four laws. They are detailed later. Each consists of a number of related observations. Combined, they are for describing in an object-oriented manner, a relative force considered common to all the four known forces. That is, what is called the strong, weak, electromagnetic and gravity. As an abstract property, relative force is considered exhibited in practical or concrete applications uniquely for the four known forces. Relative gravity's four laws are meant to be based on observations of truth. They are not considered absolute truths themselves, as observations are considered here strictly a subjective phenomenon. For that matter, all scientific law referenced in this essay is regarded this way. In other words, humans are not all-seeing, which means nothing can be absolute. The theory is intended to remain aligned with the views of Kepler, Newton, Einstein, Faraday, Tesla, and Hawking. The theory interprets, or in fact interpolates some of their work. For the paradigm they are related in the abstract for shared properties. Case in point, you must have a circle before a wheel can exist. That is, although the need of the wheel might help you discover the circle as a basic property that is shared with other things, for example the sun and moon. In each case, it could be considered a polymorphism of a property's inheritance expressed in a practical application. The views of Kepler, Newton, Einstein and Faraday normally apply to the physical context where intended. In other words, in how they see their particular wheel. In each case though, their properties, in an object-oriented way, are seen as part of their collective circle. In the theory, it is to demonstrate symmetry in the physical laws. As a simple example, one would think in terms of Faraday for explaining the principles demonstrated in the diagram below with respect to induction as a force. But if viewed as abstract properties for applying to black holes or bodies in space like a magnetized wave that transverses the universe as a pulsar or quasar, while perhaps electrifying dark into light matter in its wake, then Newton's laws also perhaps can show symmetry in derived bodies. The conceptual framework of black holes can be theorized to be like a spatial induction engine. Black holes, enigmatic entities of the cosmos, may be conceptualized as akin to spatial induction engines, operating on principles reminiscent of Faraday's electromagnetic induction, and the Einstein/Rosen bridge model. Imagine a dynamic interplay of forces within a black hole, analogous to the oscillations of an audio speaker and microphone. If we envision alternating currents permeating its structure, a vibrating disk-like core emerges as a plausible analogy. Dividing this hypothetical construct into three distinct functional components, we delve into the intricate mechanics underlying its operations. Leveraging the Einstein/Rosen bridge model and Faraday's principles, we explore the black hole's role as a spatial induction engine. The core, within this engine lies a collector cavity, where forces converge and interplay. Here, alternating currents, symbolizing the influx and outflow of energy, manifest as gravity. Through a delicate balance of opposing forces, akin to Faraday's principles, inertia yields to the black hole's gravitational pull. The manifold, as forces converge, a normalized relative force is harnessed, and contained within a temporal manifold akin to the Einstein/Rosen bridge. This manifold, stretching across spacetime, encapsulates the essence of the black hole's power, extending infinitely in duration. The resonance, a culmination of these interactions, yields a resonance, symbolized by Zr, representing a synchronistic event of immense potential field strength. This resonance, emerging from the manifold, signifies a transformative emission of energy, akin to the phenomena observed in quasars. In essence, the black hole functions as a spatial induction engine, orchestrating a symphony of forces within its core, harnessing energy from the cosmos, and emitting resonances that shape the fabric of spacetime itself. Through this conceptual lens, we unravel the mysteries of these cosmic behemoths, casting light upon the enigmatic mechanics that govern their existence. Kepler's center of gravity addresses mass as matter. Relative equilibrium does not conflict with this view when seen as the disposition of force of an equivalent relative mass. Relative equilibrium is considered proportional between paralleled entities and could, if to measure some form of Einstein's matter, be defined as E/g2 for an equivalent representation of relative mass with respect to matter as m. For the Sun and Earth, relative equilibrium is seen as a relationship of an inner and outer relativity of their relative masses. They have a shared spatial time that is derived from their covariance of relative forces. m2/d1 equals m1/d2 equals 0. Relative mass is seen as the equivalent potential energy of a body if viewed as a manifold or a uniform relative force like a sphere. This is where acceleration is measured at a rate represented as relative equilibrium with respect to some time t, such as the speed of light. Relative gravity or Rg is to account for a relative mass as manifold E/t. Based on the inverse rule, a property, relative equilibrium, Re, should be equated to a manifold's state of change. Additionally, Re can also represent the rate of acceleration of an object E/t. In application, Re is to be derived from relative gravity Rg, such as between, for example, the Sun and the Earth. This is where acceleration is measured at a rate represented as Re, or m1/d2 equals m2/d1. Demonstrated in relative equilibrium, similar to Newton's constant g with respect to Earth, gravity affects all objects the same way. But, one must go beyond Newton if to explain this similar behavior for our solar system. This is part of Re's scope. Here, disposition of force is considered proportional between paralleled entities, such as like the Sun and Earth. But also includes other heavenly bodies too. In retrospect, it is somewhat intuitive that two large magnets can respond mutually at a greater distance between them than if one is smaller, and that if the Earth were at Saturn's distance from the Sun, would the same field strength that it currently exhibits with respect to the Sun be able to keep it in orbit, or even be able to maintain the conditions known for Earth, such as atmosphere, or Newton's constant g. Re is seen as a relationship of an inner and outer relativity of relative masses, or their covariance in terms of relative forces. For example, Saturn is assumed here to have a field strength based on its size. This field strength is thought here to allow it to orbit at its own distance from the Sun, and the Earth proportionally for its ideal distances for its size. The obvious question is, can Newton's constant g apply to Saturn, or for relating the gravity between it and Earth? Mechanically, Re represents the point of balance between the relative forces of entities in Rg. It is to be generally conveyed as a relational field strength. That is, where matter A, distance relative to that matter A, but not equals to matter B, distance relative to that matter B. Re plays a major role in relative gravity. Re can further serve as a basis to conceptually fabricate a knit behind spatial fabrics touched on earlier. This has to do with the distance that is relative between entities, such as black holes, and their parts. Even the Milky Way on a clear night can be easily imagined to be like spatial fabrics of stars. The stars can also represent a lattice or knit of other spatial fabrics which make them up. This latitude in reasoning can extend gravity as a practical application. That is, in addition to solar systems, and galaxies, and in addition to their merging. The reasoning for spatial fabrics is seen somewhat different than Einstein's view. Einstein's fabrics are interpreted here as in being warped by heavenly bodies. This is regarded here, but with theory that looks more at constituent parts. For Rg, in a manner to evolution, as currents, spatial fabrics most likely warp others where relative mass aka Rm could be expressed by them. This is described later as uniform relative force or URF. Similar to a piled sheet, a primeval example is seen as the relation of heat and cold, and when and where they coalesce in Re. At a minimum, black body radiation is produced. For spatial fabrics, such as heat and cold, this is generalized for representing our universe in some form of plasma thought to consist of currents of amplitudes and voltages. As particle is implicit to galaxy, seen as fabrics X, Y and Z, all are considered to consist of unique manifolds of E/T. They are thought to be expressions of relative mass when combined in a realm of context represented as a new instance of relative mass that occupies spatial time, similar to a particle as dimension X, Y, Z. In this fabric of fabrics, Re can be considered analogous to mutual space. This is where a measure in the state of any two or more bodies as relative masses result in net zero in force. In other words, normalized through distance, body A, body B, equals zero. This net zero in force is thought of as a dynamic of proportionality where based on the inverse rule effect mentioned earlier. For Re, in offering a mathematical constant, given two bodies of different size, seen, is that the smaller has an equal normalized force with respect to the larger. This is thought to be consistent with the behavior of gravity as in affecting all things as being the same and where Newton's constant G can be applied to Earth. Given two bodies with field strengths A and B, where they share proximity, they will have a net force of zero. The relative force between A and B is seen to remain equal relative to the distance between them as a spatial time even on the subatomic level. The point of balance or quiescence in Re is represented as where there is net zero force. For an atom this could even be construed as the perception of a neutron where appearing as the net result of the resonance of an electron state and proton state of a particle, or from their combination. Essential to Re is the notion of relative distance. Noted, the actual distance the Sun and Saturn share is a relative distance with respect to a mutual force between them. This distance is considered equivalent to the one between the Sun and the Earth. Believed, this is in order for both Saturn and Earth to meet the same basic requirements in order to orbit the Sun. In other words, given their masses they are proportionally located away from the Sun. Exploring solar system bodies and gravity. When delving into the realm of gravitational waves, the concept of Kepler's center of gravity, or the seesaw analogy, m1d1 equals m2d2, provides valuable insights. This theory posits that space undergoes warping due to the presence of a heavier celestial body, thereby attracting smaller bodies in its gravitational field. Visualizing this phenomenon, particularly through table models or depictions resembling a plane or spatial fabric distorted by a central mass, aids comprehension. One can easily envision a smaller body trailing behind the larger one, while simultaneously experiencing centrifugal force urging it to veer away. This delicate interplay between gravitational attraction and centrifugal force stabilizes the orbit of the smaller body. Furthermore, one can conceive of the spatial fabric itself resonating due to the immense solar mass at its core, potentially amplifying what we perceive as gravity waves. A fresh perspective on gravity. Rather than relying solely on a two-dimensional depiction of warped space, let's consider a three-dimensional model. What if we contemplate space as genuinely warping around solid bodies? In an alternative approach to understanding gravity, let's explore the notion of gravitational fields emanating from celestial bodies, similar to Earth's electromagnetic field. Gravity, being one of the fundamental forces, can be conceptualized as a field surrounding a massive body. Considering fields for gravity. By rearranging Kepler's equation as m1/d2 equals m2/d1, and applying it to the Sun and Earth, intriguing results emerge. Surprisingly, calculations reveal that distance 1 and distance 2 converge at the exosphere level. This convergence point coincides with phenomena like the electromagnetic storm, suggesting a correlation between gravitational fields and observable atmospheric events. Unraveling the mystery of gravity. Contemplating the origin of gravitational fields prompts profound questions. Why do masses exert gravitational pull? To delve deeper, we must consider that matter comprises various forces, including gravity, matter and radiated fields. Viewing matter in terms of potential energy unveils the concept of radiated fields. Just as Earth possesses an electromagnetic field, matter itself can be envisioned as a nexus of energy and time, as per Einstein's E equals m.c. 2. Imagine the Sun and Earth as dynamic masses, each possessing unique gravitational fields resulting from their respective forces. Despite their differences, they exist in a state of relative equilibrium, symbolized by a calculated convergence point above Earth's surface. Speculating on Sun-Earth dynamics. Could the Sun and Earth share a synchronistic state of superposition, characterized by harmonic resonance and frequency modulation of their gravitational fields? Considering the analogy of electrical currents, could gravity itself be akin to a perpetual alternating current flowing between celestial bodies? In this speculative exploration, the Sun and Earth oscillate in perpetual synergy, manifesting as mutual alternating currents at a fundamental frequency, perpetually seeking equilibrium.
Can a model based on pure speculation hold as much weight as one grounded in proven hypotheses? Can we, with our limited perspective, truly grasp the vast complexities of the universe? The paradigms we form, the theories we propose, they all lead us on a quest for truth, a journey to understand the universe and our place within it. Take, for instance, the theory of relative gravity. It's a tool we use to interpret and understand the mechanics of nature, a lens through which we view the laws of physics and accepted scientific theories. This theory comes into play when we delve into the depths of atomic theory, particle physics, and the kinetic theory of matter, among many other scientific domains. Our quest for understanding does not stop there. We delve deeper, probing into the atomic particle's evolutionary process and applying this concept to known elements through a model on hypothetical matter. Of course, these two areas of focus are separate in scope, but they share a common goal: to unravel the mysteries of the universe. The theories on particles are vast and varied, each accepted by the physics community in its own context. Yet, even with this wealth of knowledge, our understanding of wave-particle duality can be influenced by the interpretations of great minds such as Steven Weinberg, Paul Dirac, and Werner Heisenberg, among others. When it comes to the known elements, we owe much of our understanding to pioneers like Hennig Brand, Johann Dobereiner, and Dmitri Mendeleev, to name a few. These scientists laid the groundwork for the periodic table of the elements, a fundamental tool in our quest for knowledge. Yet, even with this extensive history of contributions, we must accept that our understanding of the universe will never be complete. The theories we propose, such as the theory of relative gravity, are merely stepping stones on our path to understanding. This theory, grounded in the principles of object orientation, allows us to use abstract principles to understand concrete examples. It provides a framework, a structure that adopts symmetry for scientific observations. With this framework, we can begin to resolve the biases between well-founded views for string theory, quantum mechanics, and relativity. We can offer extensions on their perspectives, deepening our understanding of the universe. We are not here to prove or disprove these theories, but rather to build upon their foundations. We propose a hypothetical model for calculating atomic weights and electron counts, a model that is not molar-based. We leverage the work of others, interpreting it through the lens of the theory of relative gravity. In the pursuit of science, a clearer explanation of phenomena is always due. It is our hope that this discussion lends a sustainable direction to the theory and contributes to our ongoing quest for understanding.
In reading about Albert's rocket ship some time ago and how time slowed, led me to understand it as Fq equals ET. In other words, for Fq to stay constant, both E and T had to as well. In analogy, please consider below. In retrospect, as an EE some time also ago, I used to skew clock cycles via Boolean logic. I could make one side of the clock as long or short based on design. For the sense of universal time, one of our personal clocks of course is the second, which can be divided into picoseconds, etc. For the sake of example in the following, let's call this universal time. Question 1. Although we cannot detect if the clock cycle for our own sense of universal time is skewed or not, in observation of heavenly bodies, such as in the following, can we say that time in fact is skewed based on Fq equals ET depending upon where one is looking at the two merging galaxies? Question 2. If so, Can we also conclude that time as we know it for where we are in the spiral of the Milky Way also is different than in perhaps other parts of the Milky Way? Question 3. For our inertial frame of reference, we can possibly conclude that our sense of time is constant while also being a non-inertial reference frame in a spiral of the Milky Way? Question 4. Per Fibonacci, could we further say that our universal time in the Milky Way is subject to it? Question 5 inches. Have you thought about galaxy spirals with respect to Fibonacci? That is in terms of the characteristics of the spiral itself, similar to the following pattern. Theory for me. Theory is just my theory. Is that the fib 1.6 constant in describing the shape also describes perhaps the relationship of time with respect to acceleration toward the center and deceleration of time when spiraling out for a body in the spiral.
For special relativity, Einstein provided a thought experiment about how time slowed. This is when as a space traveler would increase her speed in space. Explained, as the rocket ship moved away from Earth, time slowed for its occupant. The popular example is to imagine flying in a spaceship where when moving fast enough it will alter its space and time. Now imagine in the spaceship a light clock which stands vertically or perpendicular to the direction of the ship. Consider the duration of the light clock as x, and z as the direction of the ship. For example, x is 90 degrees to z, which is at 180 degrees. A full cycle of the light clock x occurs when it bounces a beam vertically from its top point AC to its bottom BD and back, i.e., marking a period of time. Consider for a second in time, the interval for the light clock takes 1/2 second between points AC, or its top, and BD, or its base. If velocity of the spacecraft in direction z is at 0, then the beam bounces vertically at 90 degrees with respect to z as marking time. This applies for both an occupant of the ship and a separate observer. It would further appear at 90 degrees if both observers were in a parallel constant momentum. If velocity of z, the rocket ship, is increased, then the beam of light is considered proportionally delayed between its points. Depending on velocity, x can appear as a sine wave where points AC and BD represent half the wavelength in amplitude. When the beam returns round trip from AC to AC, it is considered a unit of its frequency. Hence FQ equals amp, vel. Given an amplitude amp and a velocity z, we have frequency FQ. Amp, Vz equals FQ. This is where FQ asterisk vel z equals amp.
Polymorphism and the principles of the delta phenomenon. The basis for an abstract model for unification is if to view the universe like an alternator. All properties are conserved in expression through polymorphism. Here, the dynamics of polymorphism are described. Generalized, the dynamics are referred to as a delta phenomenon which represents some object or entity with respect to states of expression in polymorphism. 1. The delta phenomenon is perceived as the basis of dimension that exists in a body. 2. It holds that in terms of the observance on an entity, a prior and future iteration of that entity will also exist, or the entity in its current state does not exist. 3. The delta phenomenon applies to an entity or a family of entities such that each may have a unique personification of the delta phenomenon, yet be part of the same delta phenomenon, for consequently, the delta phenomenon, although unique, can parallel itself. 4. Hence, a point of reference can be established from one category of existence to another through the relationship of uniqueness expressed through symmetry. As applied in the paradigm, these principles are considered an object-oriented model for evolution. They are detailed in the 4 laws. The 5 principles could be considered in the form of a cyclic paradigm similar to Mandelbrot sets, or a Sierpinski triangle. They are suited for an object-oriented model for the polymorphism of some entity. This is in terms of being cyclic and expressed in time and space. A delta which can represent any abstract entity as a body with respect to time and dimension can be thought to have the above principles as properties. Note how any 2 or more properties can be combined. They are thought to behave in a cyclic way where progression goes from principle 1, principle 4a, and then to a next cycle of differentiation as principle 1. As a model, The principles allow a body to have polymorphism through an inheritance of properties. This is meant to be from an earlier cycle where in each stage the entity being differentiated is expressed in terms of time and dimension. In fact, this offers Weinberg's singularity a basis for reason in juxtaposition to just observation and conjecture. Observations of truth is the basis for scientific law. Allowing it a framework or model of polymorphism for the isolated system enables reason for its conservation of properties. There is no assumption of a Big Bang as representing the beginnings of all beginnings, but polymorphism does make it plausible to have occurred. That is, even perhaps, quite a few.